In this lesson, we're going to talk about how computers see. And the process here is almost identical to how it works in animals and humans, because in a sense, we modeled this design off of understanding how animals and how humans see. And that's useful because ultimately, why do we want a computer to see? We want it to see because we want it to, be able to take a picture and show that to us, or do things similar to what we do. So it's very similar where we have light. But the only thing I will say, sorry, before we get started, is that a digital camera is basically a computer eye and brain. So if you have a digital camera, or the camera on your phone more likely these days, that's just basically one part of it is the same as like your eye plus your brain. So light is focused by the lens, just like in the human eye. The light that comes in through the camera lens is focused onto a sensor. And then the sensor array activates based on how much light is hitting it. The sensors send a signal or send several signals to the computer or the part of the computer that's interpreting that data. And then that computer interprets those signals as an image. So it's the exact same process as in the human, but just instead of it being biological components, we've engineered components to model it. Now, there are a few additional details that we kind of want to talk about of how these work. So first, the sensors. These are a bunch of sensors arrayed in a grid. So just like the cones in the back of our eye, we set up a chip that has a bunch of tiny sensors on it. And if this is just looking for black and white, we just say how much light is hitting it. But if we want it to sense, take a color picture, well, we'll make some of these sensors sensitive to red light. Some of these sensors will be sensitive to green light. And some of these sensors will be sensitive to blue light. And it'll be more organized than kind of my random drawing here, but you get the idea. We can make an array of sensors and tune them, just like our cones, to be sensitive to very specific frequencies of light. Now, unlike our cones, we can create a sensor to be sensitive to any type of electromagnetic radiation. So if we want to, say, have an infrared camera, we can tune the sensor to any frequency or type of light. So it's not limited like our eyes are to primarily red, green, and blue. We can have it do infrared, we can have it do microwave, we can have it do ultraviolet. And so that's important to know, is that this is one benefit of designing a computer, is we can basically see light that we wouldn't normally be able to through the use of a computer. And then we can have that computer turn it into light that we can see, which we'll get into later. And the activation, the reason these activate is due to the photoelectric effect. So it's because of the photoelectric effect. And you looked at this in the simulation, hopefully by now, and it's basically just when light hits a certain type of metal that's under the right conditions, it will create a current. So we've already seen how currents can send a signal. That's basically all we have here, is the right kind of light hits my metal and it sends electricity. And the brighter the light, the more electricity gets sent. The dimmer the light, the less that gets sent. And so the brighter the light, or the dimmer the light, we have brighter, dimmer, stronger signal, less, weaker signal. And eventually we encode this signal as a number between 0 and 255 usually. Now that's not always the case, but kind of for most stuff, and what we're going to work with for this class is between 0 and 255. So this blue sensor, if really bright blue light is hitting it, it might say, I'm getting 255 blue. This red sensor might be getting no red light, so it might say, I'm getting 0 red. And then you can see how if we have a yellow light, even if it's really bright, maybe the yellow light gives 150 red, because it's close to red, but it's not exactly. Same thing as the light, as the cones in our eyes. They activate based on how bright the light is and how close it is to what they're tuned for. There's nothing stopping us from creating a really, really fancy camera setup here that has, a bunch of pixels, and they're all very sensitive to very specific wavelengths of light. The problem with that is a group of these, this red, green, and blue group, really is only capturing data about one location or one place that light's hitting. So the more colors we want to make it sensitive to, the more of these pixels we have to block up to get just kind of one bit of information that we're sending out. So if we wanted to make a whole rainbow collection of pixels, this one's sensitive to red, to orange, to yellow, to green, to blue, to purple, that means our sensor has to be 6 times as large, or really twice as large as the red, green, blue. But since our eyes don't even care about the specifics of exactly what light, just what our eyes are going to do, that's why we work with these sensors in red, green, and blue. That's a bit off on a tangent, and we can talk more about it in class if you want to work out kind of the details. But the summary here is just like our eyes work. A sensor array just has parts that are sensitive to different colors of light, and then they send that to the computer, and the computer interprets it as an image. So that will wrap up how computers see.